Good morning, Tamuka. This is Diego. I wanted to record this question so to make sure that I explain it correctly. So, Tamuka, going back to rainfall, when we calculate the trend, we can see that the value on the bottom says negative 28 millimeters and 52 millimeters in this case. So this is telling us that is decreasing or increasing 52 millimeters, in this case increasing 52 millimeters for every 10 years, right? So this is already for 10 years. So in the case of temperature, we took the original temperature and multiplied by 100. So in this case, this is the average temperature for June to September. So this one is telling us that the average temperature for that period is 14 degrees, is 1400 in this case. But then here is 38 degrees and so forth, right? Okay, so when we calculate the trend for that temperature using the data multiplied by 100. So this is the trend. I need to change the colors. So green areas are getting hotter because that's increasing, and these areas are getting colder. So if we look at this, we see 3340. If we started with hundreds, so this is, I cannot explain what this 3340 is because it seems like a huge number. Even if it's 3 degrees for every 10 years decreasing, that's still a lot. So what exactly that means? That's the first question. I selected these polygons right here. You see this polygon 1, polygon 2 right here, polygon 3 and 4. And I extracted the time series for the temperature data. And this right here is polygon 1 that I transferred right here. So this is polygon 1 time series in hundreds. So this is in hundreds, and then what I did is I divided by 100 to get the original values. So these original values are, just to make sure that these original values are reasonable. So if we have these original values, I calculated the slope of that regression line for the original values would be 0.0049, and if I multiply by 10 to give it in per decade, is 0.049, right? Now if I calculate the regression line for the hundreds, this is the data that we are working with.